All right, good morning, Saintsmen. Let's go ahead and get started with lesson 1.3 regarding distance and midpoint for you guys taking notes here. A couple things that we want to make sure that we define here. The first is the idea of a midpoint. And a midpoint, by definition, is literally the middle point. And it is the point that divides a segment into two congruent parts. Okay. Moreover, you're going to see another term that's called the segment bisector. And what that is a segment bisector, by definition, is not just a point, but it could be a point, ray, line, or line segment. I'm sorry, line segment, or technically a plane, which we won't deal with that very often, that intersects a line segment at the midpoint. Gentlemen, effectively, it's also going to create two congruent parts as well. Okay, so don't overcomplicate this thing. When we actually have two congruent segments, so for example, I'm just going to sketch out here segments A, B, and C. And the way that I'm going to show that they're congruent is we will see a tick mark, a single tick mark. And that tick mark means that AB in this case is congruent to BC. It means they have the exact same length. We can use one tick mark, sometimes we can use two, we could use three. But again, it just maintains that these are congruent parts. Okay? Further, I misunderstood, or not that I misunderstood, but I didn't completely understand the notion of absolute value until I was actually in graduate school. And the absolute value of something is actually the distance from zero. I think some of you guys have seen the absolute value, and you've probably understood it as this, is if you have the absolute value of 3, it's 3. And if you have the absolute value of -3, it's 3. So it's one of those things where if it's positive, you keep it positive, and if the number is negative, you make it positive. But that's not really what we're going after here. It gives us a distance from zero. So if we were doing one of the problems like we did in the last section, and we want to find the distance on a vertical or a horizontal line between two values, so let's say that the x value stays fixed, but the y value changes, and we want to find the absolute value, or the distance, excuse me, between -6 and 2, all we have to do is find the absolute value between the two of those, which is the following. Absolute value of -6, and we're going to combine that with the absolute value of 2. And the absolute value of -6 is 6. Absolute value of 2 is 2. And that's just going to give us a distance of 8. So it's pretty straightforward. However, with all that said, one of the issues we can have is regarding calculating a distance on for a non-vertical or non-horizontal line, where we could just use the counting principle, or we actually could just use the absolute value. And we're going to use the distance formula. So first, I'd like you guys to start by creating a coordinate plane. The distance formula is going to marry two concepts together that we discussed in Algebra 1, one thing being the slope formula, and the other one being the Pythagorean theorem, which is a big guiding principle here with what we do in this course. Right, so we have the coordinate A, which I'm going to graph here, at the origin, meaning that it is at the coordinate 0, 0. Next, I'm going to put on the x-axis the coordinate C, which is over 4x, and it doesn't move up at all on y, so it's 4, 0. And last, I'm going to put the coordinate B on the coordinate plane, which goes to the right 4, or on the x-axis, and it goes up 3 on the y-axis. So it's at the coordinate 4, 3. And here's what we have. We actually have a triangle here. It's a right triangle, meaning that it follows the Pythagorean theorem. So I'm going to put the little right angle there, right at point C, the little box in the corner. And I'm going to give you guys a few more pieces of notation that we use, something just to move us forward. We will find when we start working with trigonometry and when we start working more with right triangles and actually all triangles, that we can take the side opposite an angle. So let's take AB, and that's the side that is opposite the angle C. So we're going to actually rename AB to being lowercase c. So it can be both things. We have line segment AB, which we could put a lowercase print letter c. Also, similar deal with AC. AC is opposite of angle B, so we will call this guy lowercase b. So line segment AC is equal to lowercase b. I think you could probably do the last one on your own, right? Or line segment BC is going to be equal to lowercase a. Next idea. Well, we know the distance of AC and we know the distance of BC, right? Because we can just use the counting principle or we can use the absolute value, right? I want us to consider AB. First thing is we know how to actually calculate its slope. That's something from Algebra 1. Remember how slope was identified? Slope was the variable m, which, if you had Mr. Isaac or myself, you probably heard this many times, rise over run. It's the change in y, the vertical change, rise, over the change in x, the horizontal change, run. Okay? And in this case, let's look at what our rise and our run is. Well, our rise for AB, how much it goes up, well, that's just right here. That's defined as this guy, and our rise is the distance of 3. And our run, our horizontal change, on the x-axis is 4. It's 4 spaces over. So this guy, our rise, is 3 over 4. But also, there was a deductive way for us to calculate that using a formula. So we could take the differences of the y's, right? Y sub 2 minus y sub 1. That's our vertical change over our horizontal change, which is x sub 2 minus x sub 1. So I could take the second, and again, it's a subscript, meaning it's the second point, right? And you choose which is the first and which is the second. It will come out the same either way, if you recall. So in the case of 4, 3, we're going to take 3 minus 0, and then we're going to take 4 minus 0, and it's going to give us 3 over 4. All right. So that's our review of slope. Let's talk about the Pythagorean theorem, where we had a squared plus b squared equal to c squared. I actually do this part in black. That's our Pythagorean theorem, showing that the sum of the two legs of the triangle squared is equal to the hypotenuse squared, right? So the two these guys that happen and create the right angle, and then the hypotenuse, which is opposite the right angle. That's lowercase c in this case. All right? Well, I want us to take a gander through this, and this is how we're going to do some substitution. So we have a squared. Now, let's remember what a is. A is line segment BC, which also, in this case, BC is our rise, okay? Remember that the rise is calculated, right, as y sub 2 minus y sub 1. So, effectively, I could rewrite this guy, instead of a, I could say this is y sub 2 minus y sub 1 squared. Next, I have B, right? Well, look at what B is. Again, B, which is line segment AC. Okay, AC is the run. Our run is equal to x sub 2 minus y sub 2. So I could take that, my B, or B squared, I substitute B, which is x sub 2 minus x sub 1 and we're going to square that. Next, that's all equal to c squared. And I don't want c squared. I just want c by itself because I want to know what's the distance there. What's my length of line segment c? Well, all I have to do then is just take the square root of both sides. So, big square root sign, just rewrite everything. Y sub 2 minus y sub 1 squared, right? The difference of the y squared plus the difference of the x's squared, x sub 2 minus x sub 1. And that is equal to c. Gentlemen, together we just derived what is called the distance formula. The distance, so the non-vertical and non-horizontal lines where we can't count, right? They look like diagonals, but it doesn't necessarily mean it's a diagonal. It's just what it looks like. We're going to find diagonal is defined as a different thing geometrically, but it's equal to the difference of the y's squared plus the difference of the x's squared. And that is our distance formula. We can use that between any 2 points. Call one of them x, call one of them y, or excuse me, call one of them point 1, call one of them point number 2, and then plug in our numbers and we can calculate the exact distance. All right, so here we go. I'm going to do this 2 ways. One of them is going to be the quote-unquote easy way. And it's just going to use the Pythagorean theorem. Remember that a squared plus b squared was equal to c squared. And remember that a, again, was our rise, and b was our run. Our rise was equal to 3 squared. Our run was equal to 4 squared. 3 squared is 9. 4 squared is 16, okay? And the sum of 9 and 16 is 25, and that's c squared. Now we need to solve. We're going to take the square root of both sides, right? And we get that 5, the square root of 25 is 5, and the square root of c squared is just c. And gentlemen, we don't need to worry about plus minus. The reason why? Well, you're not going to get a negative value. It doesn't make any sense there. You're not going to have a negative distance. I don't know what that would mean for a triangle to have a length of -5. It would be like inside out. I don't know. It is possible to have a negative distance in the future when you guys study physics. We will talk about that. You'll talk about that then. But for now, when we have these lengths that we're trying to measure something, there's just recalling with some sort of a ruler, right, or a tape measure, there's no negative numbers on it. I wanted to use the distance formula here just to show you that this guy works. So let me recopy those points that were up above. If you're wondering where I got them from, right, 0, 0, that's just up here. A is 0, 0. So A is 0, 0, B was 4, 3, and C was 4, 0. And we want to find what C was. So we need to find the length of AB. And our hint here is that that's the same, it's equal to whatever C is. So our answer we're going to get is going to be 5. I'm using this as an example, again, so that's intuitive for you, but you're going to see shortly, we're not going to be able to use just the Pythagorean theorem by itself. The only way we're going to be able to calculate that distance is to actually use this formula. So let's go ahead and do it. So we have the square root of, right, something and something. So A, well, I'm going to say this is x sub 1 and this is y sub 1. And for B, because I'm finding AB, this is going to be x sub 2 and this is y sub 2. I strongly recommend that you label your points for now, just so that you see where you're substituting things. It's intuitive for you. And you don't make as many mistakes. Believe it or not, you will be able to do the distance formula, many of you, mentally, not that long from now during this course when you're doing these problems. That this will be a minor step in our completion, not the overall thing we're going to. So y sub 2 minus y sub 1, okay? And we're going to square that. So y sub 2 is 3, subtracting y sub 1, which is 0. And then adding x sub 2 minus x sub 1, or 4 minus 0 squared. And already look, I think some of you guys already see how this is going to work out. 3 minus 0 is 3 squared. okay, and or 3 squared, which is 9, 4 minus 0, which is 4, squared, which is 16, and look at that. We want the square root of 9 plus 16, which is 25, so our distance is equal to 5. And again, I think some of you see, oh, well, it's just easier to do it and faster to do it the other way. That's not going to be an option in the future. I'm just proving to you that this formula is reliable. All right, so let's jump into it. This is an example of something you're going to see on your homework. We're going to find the distance between E, which is -4, 1, and F, which is 3, -1. I'm going to go ahead and just make that a little bit larger for us to see. All right, so for EF, here's how it's going to work. I need to label these things, remembering that what my distance formula is up above, okay? Distance is equal to, oh, for the record, you need to memorize this. This is not something that you're going to be able to just, I'm not going to provide this formula for you. This formula is such a critical part of what we do. You need to memorize it. All right, so there we go. That's our distance formula. Let's go ahead and determine or assign values for each of these variables. So for point E, -4, 1, I'm going to say -4 is x sub 1. That determines everything else because it's always x, y. So this is our first point E. So x sub 1 minus y, x sub 1, y sub 1. And then for F, we're going to make 3 x sub 2. It's the second point, and it's always x, y. So this is y sub 2. Now we're going to rewrite this guy and plug in all of our numbers, substitute in. So our difference here of y sub 1, which is -1, minus y sub 2, which is -1, and y sub 1, which is 1 squared, plus x sub 2, which is 3, minus -4 minus means that we're going to add, right? A double negative. Negative times a negative is a positive, so minus. Our distance. Here we go. -1 minus 1 is -2 squared, plus 3 plus 4 is 7 squared, so just keep working. -2 squared, -2 times 2 is 4. 7 squared, 7 times 7 is 49. So check out what happened here. This is the square root of 53, or rad 53, as we say. That's your answer. That's the exact answer, gentlemen. Please, leave as a radical. Do not write a decimal answer. I get that your calculator can punch out a decimal, but gentlemen, that is not the answer. That's an approximation. I don't want close enough. I want an exact answer. We're going to be really exacting in this course. Mathematics is pretty precise, so we're not trying to get what the approximation would be unless I ask for it. I want the exact answer, please. All right. Next, let's discuss the midpoint. The midpoint formula is pretty straightforward. What we're going to wind up doing is we're going to take the average of the x's, comma, it's always x, y, so it's the average of the y's. Now, that probably seems kind of silly, right, that I'm saying the average, because I'm asking you to take the average of two things. The way it's actually expressed is we're going to take both x's, we're going to add them together, x sub 1 and x sub 2, and then we're going to divide by 2. And we're going to do the same thing with the y's, y sub 1 plus y sub 2, and we're going to divide by 2. That will give us the coordinate for the midpoint. So, we're going to find the midpoint for AB if A is equal to 2 comma negative 3 and B is equal to 9 comma 0. All right. So here we go. Let's label these things, okay? A is our first point, so this is going to be x sub 1 comma y sub 1. B will be x sub 2 comma y sub 2. All right, so the way we're going to actually get this point is we're going to add 2 plus 9, and we're going to divide it by 2, comma, negative 3 plus 0, and divide by 2. What that would leave us with is 11 over 2, comma, negative 3 over 2, which, gentlemen, I will accept the answer like that. If you prefer to write it as a mixed number, which 2 goes into 11 5 times, so 5.5, comma, 2 goes into negative 3, negative 1 times, so negative 1.5. You can give me either answer, but make sure that you circle it. Our last example for today is that we are going to find D if E is the midpoint of DF and E is equal to negative 6 comma 4 and F is equal to negative 5 comma negative 3. So gentlemen, in this case, they've actually given us the midpoint. And we have to find one of the coordinates. When you have something written like this, I think it's great to sketch out what the picture would look like, right? So I'm just going to draw two line segments, right, that are congruent because there's one of them is the midpoint, and we know that E lies between D and F as the midpoint. And then further, they actually give us the coordinates here. So we have negative 6 comma 4 for E, and F we have negative 5 comma negative 3. What we don't have is D, which we know is x comma y. So if this is the case, we already know the midpoint. We know that E is equal to negative 6, and I'm going to leave some space here, watch what I do, comma 4. I'm doing this on purpose. Now remember what our formula was here, right? We already know E, but the formula we used to find E was x sub 1 plus x sub 2 over 2, and we had for the y, to find the y portion, which is 4, it's y sub 1 plus y sub 2 over 2. Or we already know something. We already know that negative 5 comma negative 3 is x sub, is x sub 2 and y sub 2. So we need to find is this other coordinate. So I'm going to go back here and I'm going to substitute in here. So instead of x sub 2 and y sub 2, I'm going to make sure I have my values in here. I have negative 5. And remember, when you substitute, it's a great idea to put it always in parentheses. But now what I'm left with is I'm effectively left with two separate algebraic problems. I have negative 6, which is equal to, and it's just one x we're looking for, so it's x minus 5 over 2. And then on the other side, I have 4, which is equal to y minus 3 over 2. And I can actually use these to solve for x and y to get our coordinate for D. And now we're just doing a regular two-step algebra problem. So I'm going to multiply both sides by 2, right? Factor that out. I'm going to have negative 12 is equal to x minus 5. Okay? I'm going to add 5 to both sides. To cancel that out, negative 12 plus 5 is negative 7, and that's equal to x. On the other side, start out by multiplying by 2. Okay? 2's factor out. 2 times 4 is 8. Y minus 3. I'm going to get the y by itself, so I'm going to add 3 to both sides, in which I get 11 is equal to y. Gentlemen, that's my coordinate. D the coordinate D is equal to y comma x, or -7 comma 11. That is your coordinate. And of course, make sure you circle your answer. If you have any questions, feel free to reach out to me, either in the chat right now, or you can feel free to email me. Please start assignment 1.3. Good luck.